Awesome. So today we do have a lot, the good news is for the exam, and so whatever we don't finish today, we'll finish on Wednesday. I do want to point out on Friday, I opened up 2 more homework, so 1.6 and 1.7, even if we haven't hit 1.7 yet. I wanted to open it as soon as possible so you can work on it. Quiz 1 and quiz 2 are also out. We're not gonna have a quiz 3 yet because I just consider the exam being our quiz for the week. But I do want to point out, like, it's better for you to attempt the homeworks and the quizzes and not do well versus just to skip it. That's my opinion. I'm not gonna say I'm always gonna be right, but that's just what I think is best. Because I'd rather you drop maybe a low grade that you at least attempted versus just not even try at all. Because the quiz is what I've based it on, is what we cover in class. And it could really help you on those exams, especially if you try to do those quizzes without notes for at least one of those trials. Yeah, that's gonna be due at 11:59 a.m. on Friday. So try to get as much as you possibly can before then. I think that's pretty much it about the deadlines. Any questions on deadlines?
So exam 1 will include the 1.6 and 1.7 as well.
Yes, so what I did was I took and said, we have 3 units this semester, all 3 units are for each exam. And so everything in unit 1 will go into exam 1, everything in unit 2 will go into exam 2 and 3 and exam 3. So I thought that might be a little bit easier for y'all to kind of figure out what's going on in the exam. So yes, 1.1 all the way to 1.7 are going to be in the exam. If you would like to get some practice, I will be coming into lecture, and when we have extra time, I will be doing practice problems with you. And if you go under modules, there is exams from fall of 2024. I want to point out that in fall of 2024, Dr. Patterson did 4 midterm exams where we're having 3 midterm exams. And so for unit 1, that's going to be exams 1, 2. So you look at both exams from those practices. So you can see, how do the exams look? It's about 35 questions and multiple choice and a short answer. I might make them a little bit shorter for us because I want to get it in 50 minutes. But that's gonna be how you can practice. And I'm pointing that out because I don't really like it when students procrastinate to do all the homework and the quizzes instead of studying. They do help you study, but the best way to get prepared for the exam is to take a look at those practice exams. And I'll kind of tell you what I learned way too late in life, because when I was in y'all shoes, I would be doing my homeworks up until midnight the day before the exam and not studying. The way that you study for chemistry is practice, right? But how are you going to be here in the exam? Are you going to have an equation sheet? Are you going to have this and this and this? You're not going to be given those periodic table of elements with everything labeled. You're not. So you want to practice by first doing practice questions with your notes. And then once you get more comfortable, take the notes away and attempt to do the practice problems without any assistance. Would be a blank periodic table of elements, you can have that. Your calculator, and that's it. So you want to get to a point where you can answer practice problems without assistance. And that's where I feel like myself, when I was doing my bachelor's degrees, and students today make that mistake, is that they study with their notes. And that's why you want to get all of the hard stuff out of the way so you can practice and practice and practice without your notes. And that's when you know you're ready for the exam. That's just my skill, just because I made the mistake so many times. And I just want better for y'all. So we're going to finish unit conversions, and then we're going to hit verse, and I have a work for verse. And lastly, I want to start the 1.7 chemical equations. So I do have a lot I want to cover today, but the downtime with that verse activity. Online, if you would like to download the verse activity, it is published. I have 3 links online. You have a formula sheet first, because you need a formula sheet. You have the assignment itself that has the math answers at the very end. And then I felt like, since it's now math, let me write up a key. And I've included my key, the way that I answered everything, additional. So that's available to you on our modules. Okay, let's go to unit conversions. Let's just remind you that you're not going to be given these conversions in front of you for the exam. There are certain conversions you want to be very comfortable remembering. meters to kilometers or meters to millimeters. Those are, I think, are kind of ingrained in us, but if they're not, just keep practicing. Sometimes you might have to go between one thing and another, and then go into another. So we'll get there in a bit. First, if it says convert this number from meters to kilometers, what is the equivalence? How many meters are in 1 kilometer? 1,000. There are 1,000 meters in 1 kilometer. If you go back to that units table, it did say that under meters, everything was 10 to the 0, and kilometers, it was 10 to 3. So another way you can write it, this is 1 times 10 to the 3 meters equals 1 kilometer, or 1 meter equals 10, or I need to get myself off that. 10 to the minus 3 kilometers. All of these equivalents are correct. I don't want you using what you don't like. So whatever you feel most comfortable, write it like that. I know what you're doing. Is with this one, I just want you to make sure you're putting it the number in the right location. But I tend to do this one. So always start with what you're given. We are given 4.2 times 10 to the minus 6 meters. And then with the conversion, you want one on top and what you're given on the bottom, so the given will cancel out units. So that would be meters on the bottom. So I'll do 1,000 meters and 1 kilometer on the top. That way, meters cancel and I'm left over with kilometers. So 4.2 times 10 to the minus 6 divided by 1,000. This one you can do in your head because, you know, 10 to the minus 6 divided by 10 to the minus 3. Do y'all remember what that gets you? So minus 6 minus, yeah, so it'd be minus -3. No, minus 3. I think so. So it should be 10 to the 9 because you subtract them.
So -6 minus -3.
Yeah, but it should be -9. But that's how the answer should be 10 to the minus 9. I'm not sure why I'm having a blank right now. But I got 4.2 times 10 to the minus 9. And double check in your calculator because make sure I'm right. Double check you're putting the e's in. So e minus 6. And then you can divide it by 1,000. And I got, yeah.
Would it be 10 E minus 6 or just 1 E minus 6?
My advice is do 1 E, or for this one, it would be 4.2 E minus 6. And if you want to divide it by 1,000, you could do 1 E to the third. Oh, that's where I went wrong. Yes. Okay. So 10 to the 6 divided by 10 to the third. I went wrong.
Oh,
I'm like, we knew this didn't make sense, right? So let's fix it. We fixed it. So that's why it's 10 to the minus 9. I love it because I'm human. I make mistakes and I'm able to like be like, that doesn't look right. Let's fix that. So that, yeah. So I'm always going to include my units and then there is my final answer, 10 to the minus 9. So converting, we're now going to be going between two prefixes. So previously we kind of went from the standard SI unit, like meters, grams, like our baseline. But sometimes what happens if you have to go between two things, going maybe between kilometers to millimeters. So I'm going to show you two different options how to do that. You pick what's best for you. There's no really one approach, but I will gladly show you two different approaches. So one of the easiest ways you can do is that you go from the prefix before to the metric standard, and then go from the metric standard for what you're looking. So it's a two-step conversion. Another way, if you're really savvy with math, is that you can just skip a step. This one says convert 75 kilograms to milligrams. So first, let's do option 1. Option 1 would probably be the simplest, is you go from kilograms to the standard unit of grams, and then go from grams to milligrams, because we all kind of know how to get back to grams, where going from kilograms to milligrams might be more difficult. So 75 kilograms times We want grams on top, kilograms on the bottom. And then we finally want to get where we want to go, which is milligrams on the top, grams on the bottom. That way, units will cancel and we're left with milligrams. The conversions would be, there are 1,000 grams in 1 kilogram, and there are 1,000 milligrams in 1 gram. So 1,000 kilogram, 1,000 gram. Then 75 times 1,000 times 1,000. I get. Yeah, it should be 75 million. This is like me just not trusting my brain. 70 or 7.5 times 10 to the 7th milligram. So 75 million or 7.5 times 10 to the 7th. Make it a different color. Here's how you could skip step. You have to be very comfortable knowing where they're at on that metric table. So if I go to that metric table, I know kilograms at 10 to the 3rd, because there's 1,000 or 1,000 grams in 1 kilogram. And I know milligrams are 10 to the -3. So I'm kind of going off that metric table. What is the difference between kilograms and milligrams?
1,000.
Not 2,000, so it's 1,000 times 1,000. So you have 10 to the 3 all the way to 10 to the -3. That's 10 to the. So 1,000 times 1,000, it's a million, right? So the difference between them would be 10 to the 6th. So I see where your mind, you doubled it, but unfortunately, just multiply it. So the difference between kilograms and milligrams is exactly 1 million. So here's option 2. There are 1 million milligrams in 1 kilogram, because there's 1,000 milligrams in 1 gram, and there are 1,000 grams in a kilogram. 1,000 times 1,000 is a million. So essentially, I'm skipping the middleman here and just going from straight to kilograms to milligrams. And that gets you the exact same answer. So now I tend to do this method back to my standard metric units. But if I was to need to be challenged, I can always do this based off knowing the difference between them. But you know what works best for you. I would say option 2 is a harder, more challenging method, and it truly makes you know the difference between them for you to do that. So I would probably not skip that step if you weren't truly comfortable. Any questions on that? Now let's go from millimeters to nanometers. So if I want to go, so we're going to do option 1 again, where I go from, even if it's on one side of it, I tend to do option 1 always as a habit. How many millimeters are in 1 meter? 1,000. And then if I'm going from 1 meter to 1 nanometer, are nanometers smaller than a meter or bigger?
Small.
Much smaller. How many nanometers are in 1 meter? 1 billion. Yes, so it's micro would be 1 million. Yeah, this is more of how comfortable you are with that.
Yeah.
And it's just going to take some time. So there are 1 times 10 to the 9th nanometers in 1 meter. So before you kind of hit these conversions, you want to make sure you kind of know those equivalent conversion factors. So option 1. 3.5 millimeters, and I'm going to convert it to meters because that's my standard. And then I'm going to convert from meters to nanometers. So 1 times 10 to the 9, because it's much smaller. If you want to throw that -9 in, you have to put it under meters, not nanometers. So my units convert, I'm left with nanometers. I get. $3.75 times 10⁶. Double check my math because now the math's getting a little bit more complicated. So take 3.75, divide it, or you can do 3.75 times 1E9, enter, and then divide that by 1,000. Which makes sense because if you divide anything to the 9th power by 1,000 or 10⁵, you'll get 10⁶.
We not go from the millimeters to micrometers, nanometers.
So you could, that's one extra step. But if you know between meters and nanometers, you don't have to stop at micrometers. So you got to do its best, but hopefully doing these different methods, I can help be a little bit more efficient. So that would be more like saving you a step. For option 2, you don't need micrometers, but I just want to challenge you real quick. So for meters, that's just 10⁻⁴ power because that's our standard base unit of 1. For millimeters, that would be 10⁻⁻3. Micrometers, 10⁻⁻⁶. Nanometers. Okay, so we want to go between millimeters and nanometers. What's the difference between them? 1,000,000. So the difference between them is 10⁶. So this is when we can kind of skip steps here. And this is how I kind of would do this in my head, is knowing the difference between them. There's 1,000,000 difference. This is like my shorthand little cheat sheet for myself. Can I erase this or y'all doing it still? So option 2. There are 1,000,000 nanometers in 1 millimeter. But this is millimeters, not nanometers. So I want nanometers, so that's break that habit of my own. You should get the same answer.
The denominator on the second one, should that be meters?
Yes, thank you. This is 1.6. Sorry for the delay in getting back to you, Fernando. All right, any more questions on that? All right, the last slide I'm gonna let y'all go through because it's now flipping it, going from nanometers to meters. So you pick what option you prefer, so nanometers to millimeters, and go ahead and answer it. I'm always making revisions to the building in the summer. Does everyone have it? What did you get?
6.33 times 10 and then.
Yes. So I got 6.33 times 10 to the minus 4 millimeters. And if you prefer to write it with zeros, 0.00063. Both of them are correct. All right. Let's move on to verse. Oh my gosh, it'll go away in a minute. This section is going to be a lot of math practice. So if you haven't gotten your calculator out, please get it out. So you know, check my math, make sure we're on the right page. This section is going to be more about training us how to answer word problems that use chemical formulas. It might seem really redundant if you're with letter math, which we did last class. But it does get it, when I start introducing numbers, that's when students will get a little make more sense of it. And then once we're comfortable with this method, it just makes formula questions so much easier. So be patient with me while we go over it. And then if you are on the side of this is too easy, you're welcome to skip ahead. Or if it's not, please, you know, work with me. I'm gonna take my sweet time because I feel like when I teach general chemistry all the way up to quant, this is something students struggle with. So verse is a method. Those are gonna be our verse worksheets. So there's two major problem solving techniques. We've already discussed dimensional analysis. That goes kind of with unit conversions. It's not really using a chemical formula. You have to come up with those equivalents and then be able to go from one thing to another. Another main way that we ask questions is using equations or chemical equations, formulas, and have you plug in numbers to solve for an answer. They include variables or letters, and they include a lot of units. So we're going to do a lot of practicing with that. So verse stands for variables, so letters, equation, you know, being able to figure out what equation, because sometimes you're given an equation sheet, you get an equation to pick from, that's a major issue. I've definitely hit that where I'm like, I don't know what to do. Rearrange, so solve for what the problem is. Substitute and solve. Sometimes they're a little mean and they give you an answer or a number that doesn't match the units. So you have to do a little bit of changing, rearrange it, and then solve. And then evaluate is the main thing that I feel like a lot of us forget. Does our number make sense? So try not to skip that because we want to make sure we can catch our mistakes. And you can see we've been evaluating my mistakes this whole time because I'm big on, okay, does it make sense? Because I honestly, I type things in wrong all the time. All right, variables and equations. So read through the problem to identify the variables. They'll give you different numbers, and I'll tell you further on in chemistry, they're not always nice. They'll give you these numbers that don't matter. Like, okay, room temperature is 25 degrees, but the chemical equation doesn't look great temperature. Sometimes they're mean like that. For us, will be very nice, but it's going to be very important to like be able to read through those variables and say, do they matter or not? What do I do with them? What are you given? What are you trying to find? What important information may be a necessary problem, but not a part of your calculation? That would be what I was giving. We'll give you like the room temperature is 25 degrees Celsius. So that's not going to be a part of your problem, but it's relevant to the big scheme of things. The only time you can use this problem, the temperature is 25 degrees Celsius, things like that. So E, what equation connects these variables? As you move on in chemistry, we deal with a lot of different chemical equations. If we're dealing with gases, we'll use the gas law equation. If we're dealing with concentration, we might do a concentration equation. If we're dealing with energy, we'll use something from thermodynamics. Well, it's asking for energy. I can't use a gas law because there's no energy involved in that. So make a list of the variables, including their symbols, numbers, and units, and convert any units that are not compatible. That's a big thing that students tend to skip because they sometimes will panic on the question. So we're gonna do all of that. Rearrange. This is going back to letter math. So if I give you an equation, I can ask you to answer this question. I can say solve for Q, solve for M, solve for C, solve for delta T. I can ask you to do anything, but that goes back to being able to do letter math. So if I need to rearrange it, remember that if I have multiplication over here, I have to get rid of it by using the opposite, so division. Delta T, I'm gonna skip some steps because we haven't hit it yet, but don't worry if it's a little bit too much, but delta T equals temperature final minus temperature initial. So if I wanted to figure out what is temperature final, I have subtraction right here. So division on both sides. So rearranging the letter using the opposite math, that's your C. So just take some practice. If I was to make, I don't know, let's do. If I started using exponents, the opposite of an exponent is like a square root. So to get rid of that exponent, you would have to square root sides because that's the opposite. This is just what you might see. So go in the reverse of the orders of operation. And if you do it to one side of the equation, you have to do it to the other. So verse, substitute, and solve. So substitute the numbers with the units for the variables into the rearrange. So once you've identified what equation you need, you've identified the variables that go into it, and you've double checked your units. Now you're adding in those numbers and you're solving for what it wants. So calculate a numerical answer and do the same math operations to the units to find the unit of the answer. I do it all at once, is I will put my numbers and I'll put my units next to it, and I will double check everything before I answer it for real. So I'll show you how to do that. And then lastly, this is the one we all forget. Evaluate. Does our answer make sense? If you know your answer should be really small, your calculator is spitting out something big, maybe you forgot a parentheses or another sign there. So make sure it makes sense before you answer it, because that might be causing, you did all the hard work, but that one last thing in your calculator prevents you from getting the right answer. And that's fine for a short answer problem when I can give partial credit. But for a multiple choice question, unfortunately, there's all your points. So we're trying to avoid that. So does the unit derived from the math match what you expect variable? If not, maybe there's a conversion error in there. And then what meaning does the answer have? So that's really big. And we're going to try to hit all of those for each of these problems. As you get more and more comfortable, you can definitely start skipping steps. But this is for learning the basics to make our lives easier when we hit either 1341 or 1335. So our goal from this is to be able to be efficient, to use our calculators efficiently and effectively, and most important, accurately answer. So if you have, and I'm kind of unlearning my own bad habits with you, because I teach or learned a certain way. So I'm doing it with you, and we're not, because you see me always writing 10 to the 6th, and I want you to type into your calculator 1 times 10 to the 6th. I'm trying to relearn my own things, because it's easier to type 1e6 than do 10 caret 6. So do what's best for you, but the goal is to make your lives a little bit easier. So I have some of these. So using parentheses to mean multiplication. So this is mostly to save time. Is sometimes instead of doing a million parentheses, you can just do multiplication in the right spots and then just do 1 parentheses. This is another thing. You won't get the wrong answer if you do this, but you might get some rounding errors and you might make some math mistakes. So we want you to be able to do all of the math at once to save you time. So doing part of the calculation, writing down the intermediate, and then doing it again. So it'll get you the right answer if you do everything right, but it will slow you down. And then sometimes students will make a math error in that first part and it screws them over for the next part. And we don't want that to happen. And then entering a number and scientific notation any other way than using the E key. So 1 times 10 to the 6th versus 1e6. This involves so many more buttons, and more buttons mean more chances to make mistakes. So this is just the easier, more efficient way. Multiplication and division, just calculators, start with the number on the top. So typically if I give you, we did this in unit conversions where, like I said, 3.75 millimeters to kilograms. No, it's never gonna happen. Kilometers. If I was to give you something, it's always assumed it's divided by 1, but you don't need to include that in your math. So that's why you just want to assume it's always on top. So hit the times key before all of the numbers, hit the divide key whenever you need to, and then enter the key after the very last number. So it's just basics. So obviously we're all comfortable with that. We're going back to what we did, I think it was day 2. So let's just do some practice. But I do want to point out there are 2 ways to answer these types of problems. You pick what's best for you. I like my stickler for being a little slower, where I kind of visualize it like this, and I type it into my calculator like this. That's one way to do it. Another way is kind of like on the bottom, where you kind of take all of the top, multiply them together, and divide it by all of the bottom. So you pick what's best for you. I will never tell you you're wrong. Just go ahead and answer it and get the numbers for both of these. For the first, what did you get?
83.56.
I also got that. Now, let's go back to kind of sig figs. Out of all of these, which one has the smallest amount of sig figs?
0.2.
Yes, that one has 2. And so if you were to answer this in 3 sig figs, I don't think you'd be wrong, but let's just get into the habit of checking. So this one, I would say it's, so 83.56, that 6 would make it 80. Actually, if it's only 2, it would make it 84. I'm just gonna do 3 sig figs. Yeah, I'm kind of breaking my own rules, sorry. What about this one?
0.482.
I got 0.92 something. Let me double check, because it might be me. Don't ever round until the very end. If you ever need to round, just don't round the numbers before you type them in. I know sometimes there are a lot of numbers. Okay, I got 0.9259. I'm gonna just double check me. Don't forget this 0 up front. Sometimes I'll forget that in my math too. Did everyone get the same numbers as me?
Yeah,
Okay, alright, thank you. I was
What
like,
did you guys say?
I got 0.9259 something. If you didn't, let's go back to double check. So when I typed it in my calculator, I did 36.7 times 0.0. Don't forget this 0 right here. 22556 times 36.892. And then I closed parentheses, divided 45.7 times 0.7217. So that's how I typed it in my calculator.
I didn't use parentheses at first, and I just did, but then after I did like, I just multiplied all the ones on the top and then. hit
Enter, yes.
Yeah, and then did all the ones on the bottom.
Yes.
Those two.
That'll get you the right answer, but if you kind of do it all at once and don't include that parentheses, that'll get you the wrong answer.
Did you? Guess it's really stupid for it.
Yeah, so I rounded it 0.9259. I rounded it to 0.926. So multiplication using sig figs. Count the number of sig figs and all of the numbers you are multiplying and dividing, identify the smallest number of sig figs, and then round your answer to the smallest number of sig figs. And I'm gonna just do another little tip. Do not round until I can't spell. So if you do intermediates, don't round the intermediate. If you're doing several steps, don't round anything until the very, very end. Because sometimes if you round too early, your overall answer will be a little bit further off than the real answer. And like, let's say if you're doing multiple choice questions, it might be closer to another answer. And we want to make sure if you're gonna round, like, you'll be might be a little off than the real answer, but be close enough where you're like, that's definitely the answer. Now we're gonna put it all together using this equation. You won't see this equation until you hit thermo during Gen Chem 1 or engineering. So this equation, obviously, I'm never gonna like have you memorize the equation, but if I was to give you variables and give you numbers, can you answer it? So this is it's an energy equation. So I always kind of shorthand it, say Q equals MCAT because it looks like a cat, but is energy. So Q is heat or transfer of thermal energy, and it tends to be in joules. Sometimes they'll give it to you in kilojoules, but I'll show you why you want to really keep it in joules. M represents mass in grams. C is the specific heat capacity. It's usually in these units. So joules divided by grams degrees Celsius. So if your specific heat is in joules, you want to make sure everything is in joules. If you were to have it in kilojoules, the units would never cancel out properly. So if your specific heat is in joules times grams Celsius, you want to make sure joules is going to be your energy. Delta T is the change in temperature. And when you see delta, typically delta is just final minus initial. So delta T equals temperature final minus temperature initial. And it's typically given to you in degrees because if you go back to specific heat, it's degrees Celsius. Because you want to be consistent. So you want your mass in grams, you want your energy in joules, and you want your temperature in degrees Celsius. If you look at the worksheet a little prematurely, I'm trying to make you do these conversions before you answer it. But this is just a key step of make sure your units make sense before you plug anything in or you won't get the right answer. Okay, let's practice. This is when, like, if you don't quite know how to answer these problems, that's where we kind of panic and just don't know how to start. But we're going to use verse. Labs often use the combustion of methane in a Bunsen burner to heat samples. So that first sentence, cool, but it's not relevant. Doesn't matter, but it's just a way to make the questions a little longer. Talked about real life. Find the heat required from the combustion reaction to raise the temperature of a 0.25 kilogram of water by 45.6 degrees Celsius. The specific heat of water is 4.184 joules per grams Celsius. So it's a mouthful, but verse, identify the variables. So I'm going through it, and at first I'm gonna say mass is 0.250 kilograms. Then it says temperature. They only give me one temperature, so I can assume that's our delta T. And then next it gives us C, which is 4.184 joules per gram Celsius. Now, here is where I always will point out before I even start, because I don't want to start and miss this. My specific heat is in joules, but I'm circled the wrong thing. But my units in my specific heat are grams, so kilograms to grams. So I'm going to have to do something before I can get started, which is do a quick conversion from kilograms to grams. So. I always do this before I get started because I feel like if I start right away, I will forget this. So I convert my mass to grams, that way all of my units will make sense. And now I can get started. So we've identified our variables. Next will be equation. This is going to be using the Q equals MC delta T. And the good news is I don't have to rearrange this because it's already solving for what we want, heat. And the other good news is they give us all of the variables. So once your variables are converted, you can plug everything in. 250, always write your units. Because this is when you can also catch, is the kilograms wrong or right? You can figure out what your answer will be in. This is how you can do it. We have grams here in the numerator, and we have grams in the denominator. Therefore, they cancel. We have degrees Celsius here in the numerator, and you have degrees Celsius here in the denominator. There's nothing left for me to cancel. So my answer is going to be in joules. Double check my math.
This would go down to 3 sig figs.
Yes, that was gonna be my next thing. This is my right answer, and that's why, like, if I was to do for me, not for what I'm highlighting for someone to grade, I would go back up here and I would find that the lowest sig figs are gonna be 3. That this is 3, this is 3, and this is 4. So because 3, I want to make sure I round to 3 sig figs. So that would be 477 0 0 joules. You can also use scientific notation, but just double to make sure my numbers are correct. I kind of did all of this math pretty fast before class. Great. We're gonna be doing this a lot in the next few slides, a lot of math, but now we're gonna start doing some rearranging. It'll start getting redundant, but what I like is it starts sticking with you a little bit. So sorry if I'm a little annoying in the next few slides, but it's gonna be a lot of fun from my perspective. I love that. Next, something similar, it says finding mass. So we're using equation, but we have to do a little bit of letter math. A chemist, millimole, needs to heat a sample of water from room temperature to 35 degrees Celsius. A change of about 30 degrees Celsius. If her Bunsen burner can provide 2.567 kilojoules of heat, what mass of water can she heat up for this experiment? The specific heat of water is 4.184 joules or grams Celsius. Now, V, variables. This is when they throw in information to us that we don't quite need. They gave us a final temperature, but they did not give us an initial temperature. They gave us the change. So I don't want you to think that this is going to be delta T 35 minus 13. That's not what it's giving us. If I reread the question, it's saying heating it up to 35 degrees, a change of about 13. So I want to make sure I'm reading the question right and identify that delta T is equal to 13 degrees Celsius. That might be one thing that a student will kind of misunderstand and get right the wrong answer. So sometimes they are trying to trick you. So next will be Q. It gives us heat, 2.567 kilojoules. And then we don't know what mass is. So you can also, sometimes I'll do this and I'll do like a question mark to say like, we're trying to find mass. And then C is 4.184 joules per degrees Celsius. And you can do this now or you can do this later, but I like to do this now. Oh, I want to do a different color. Do I need to make a change here? Because for me to do this all out, if I was to leave it in kilojoules, my answer would not be correct. I need to convert 2.567 kilojoule to joules before I can do anything else. To do that, just multiply it by 1,000 because that's conversion. So that'll be 2,567 joules. So I'll do a little arrow up here, 2.567. Now let's move on to the equation. I want to isolate M. So what am I going to do?
C delta T.
Yes, and you can do both because they all have the same type of math. So I can divide by C delta T on both sides. That way they cancel. And now Q, or sorry, let me write it. M equals Q divided by C delta T. And we can plug it all in. Because we did everything else, we rearranged that, we just rearranged, that would be R. S would be double checking the units and putting in the numbers. So we're on S right now. So that's going to be 2,567 joules divided by 4.184 joules per gram Celsius, and then 13 degrees Celsius. The units should always work out. I have joules in the numerator and I have joules in the denominator. Sorry, well, I'll start my break after I finish this one. And then I have degrees Celsius in the denominator here, and this is like in a 1/1 degrees Celsius, so that will cancel. And now I'm left with grams. So this is what I mean. I have 1 divided by 1 divided by grams, which is the same thing as taking 1. It's like where you flip it. This is just like going back to, I feel like it's so ancient for me, going back to like high school algebra 2 or college algebra, maybe, I think. So that would be why it's equal to grams. And I got 47.19 grams. Is that the final answer? What should it be? So look at the sig figs. Huh?
There's 2 sig.
So this one is 3, this one is 3. So the 0 after the decimal will count if they've already had a non. So I got 47.2. Did y'all get that? Sorry, these slides are getting very messy. You'll see it in my key. My key looks the exact same as this. All right, so I have 12:51. Let's come back at 12:56. Y'all go take a mental break. Pause the recording. Okay, let's move on. This one is using the exact same equation, but now we are finding specific heat. And they even kind of went one step further. Specific heat is a number that's used for a particular compound or pure element. If I was asking you about water in the liquid state, that's why previously we used this number, because every question previously was using water in the liquid state. But in this problem, we're not using water. So it's asking a chemist, Bobcat, needs to identify a sample of metal which has a mass of 0.0592 kilograms. His Bunsen burner can provide 2.567 kilojoules of heat, and it heats up the sample by 97.6 degrees Celsius. Which of the metals in the table might be the sample? So we have to do one step further. We have to do all the same math as before, figure out the specific heat, and then using the number that we got, compare it to this table and figure out which one it's closest to. So 2 steps. But I like this because this is a real life example of what you might see. So figuring out what an unknown might be. Let me write the equation. So Q equals MC delta T. So V for variables. If I go through the problem, I have mass equals 0.0592 kilograms. But remember, I want everything in grams because if I go here, that's the wrong color. It's in grams. So that's gonna be my first step is I need to convert this to, so. That's 59.2. Next, it gives us kilojoules. So Q equals 2.567 kilojoules. And just like the other one, I need to convert that to joules because the specific heats are in kilojoules. And if I solve for a specific heat that was in kilojoules per kilogram degrees Celsius, it wouldn't get me the right answer. So I'll do the same thing. You'd multiply it by 1,000, so that's 2,567 joules. Then it gives us delta T equal to 97.6. That one we don't have to mess with. It's in degrees Celsius. Next, I want to isolate C. How do I do that? Yes, divide by M delta. So that's the R is the rearrange, and then the S would be now we can plug in those numbers. So if you prefer to do all the unit conversions after this step, you're fine, just don't forget to do them. I need 7 things. Then I need to make sure my units will cancel, so nope, they're not supposed to. My bad. All right, so C. Ooh, I'll let y'all do the math. What'd you get? So the question is not asking for the specific heat, it's asking what metal it is. What did you get? Iron or Fe. All finish the question. So that's when you want to make sure you read question twice and just say, with multiple choice, it'd be probably easier because it's probably, you only have different metals. But if this was a short answer problem and you forgot it, you'd probably lose a few points. Okay. Now let's start using delta T. So finding change in temperature. Sometimes the questions are not always going to be so nice and give you delta T, so you have to solve for it. And then sometimes they're really not nice. And look at number 2. It says, figure out one or the other partial temperature. So let's do number 1. If you add 3,574 joules to a sample of 100 grams of water, how much does the temperature of the water rise? So that is looking for delta T. The specific heat of water is 4.184 joules per gram Celsius. So Q equals MC delta T. Let's do our variables because that's V for verse. So our Q equals 3,574 joules. Oh, they were nice. I don't have to do any conversions. M is 100 grams. Same thing. Nice. And C equals 4.184 joules per gram Celsius. Now let's rearrange. So we're looking for delta T. So how am I going to isolate delta T? Divide by MC. So S, we now substitute everything in. 3,574. And our units should be, we're looking for degrees Celsius. So the joules should cancel, the grams could cancel, and now we have 1 over degrees Celsius, which is the same thing as degrees Celsius. And I'll let y'all plug in and tell me the answer. Does anyone have an answer yet?
8.54 degrees Celsius.
8.54 degrees Celsius. That's the answer for number 1. That's going to be our delta T. And then question, how many sig figs are in this number?
3.
3, because that period, it makes it 3. If there is no end of it, how many?
2. 1.
Yes, 1. So I'll keep my answer in 3. I don't want to erase all of this hard work. He's the wrong one. So from number one, we found that delta T equals 8.54 degrees Celsius. Number two says if the water starts at 4.2 degrees Celsius, what is the final temperature? So delta T is equal to TF minus TI, so final minus initial. We want to figure out what is the final temperature. So to do that, I need to get rid of the TI. What do I do? Add it on both sides, that way it cancels. TF equals delta T plus TI. And so delta T, I already wrote delta T is 8.54 and then TI equals 4.2 degrees Celsius. You don't need parentheses. 8.54 degrees Celsius plus 4.2 degrees Celsius, and then I get 12.74. Which I guess if I was to round, because now we have 2 as our lowest amount, it'd be 13. How do you feel about that? Awesome. Sometimes they're not all gonna be so nice. They will take a question and instead of making it 2 parts, they will not ask you what is the change in temperature. They will just put them all together. So this is when we go to the next step. How do I go from delta T to TF if it doesn't explicitly ask me how to solve for delta T? So if you get that question, always solve for delta and then you can go one step further. So let's go back to sig figs. Round your answer to the same place value as the least precise measurement. This would be more of like a lab. So if the lab can only do sig figs to 2 decimal places, that's when you probably want to have your answer to the same method. So the last sig fig and the largest value, the last sig fig is furthest to the left. Most of the time, this is the same thing as rounding to the smallest number of decimal places, but this is just the specific rule, and it's just like a good thing to practice. So calculate and round. First, always plug into your calculator as is. You never want to round anything until the very, very end. So answer these questions and then we will use those rules. And when it says least precise, that's just going to be the last decimal place. The fewest amount of decimal places, that's your least precise. This is what we mean by least precise. So if this is multiplication division, we would probably go off of the fewest sig figs. I mean, the good news is sometimes it works out in the end, but this is 4 sig figs, this is 4 sig figs, and this is 3. The reason why it's correct is because it's subtraction here, and the least precise value goes to 2 decimal places, so our answer goes to 2 decimal places. For this one, the least precise one goes to 1 decimal place, so that's why I wrote it to 1 decimal place. Now here's one that works out. This one is 4 sig figs, this is also 4 sig figs. And then the last one, I had to add a decimal place because they both go to 2 decimal places. So that's the least precise, and so if I plug it in my calculator, it saves space, it gives me 53.7, but the least precise is to 2 decimal places, so I just added 0 on the end. Right, so once again, multiplication, division, fewest amount of sig figs, addition and subtraction, the least precise, so fewest decimal places. Now let's do it one step further. Calculations with multiple steps. This is when you want to kind of break it into 2. Because this is in parentheses, do this first. Figure out the sig figs, remember, so fewest decimal places, you want to have 2, and then you can multiply it and then do it to fewest sig figs.
So round the 5 sig figs before multiplying by 7.9.
So I didn't round to the specific sig figs, I rounded to the second decimal place. So it probably would work out in the end, it's 5 and 5, so yes, that would work. But I specifically wanted to make sure that it's to 2 decimal places. So you want to round in this step, because now we're focused specifically on sig figs. We want to round first, so 115.05, and then before you do this, you will plug it in, and then now it's multiplication. We will focus on 5, and I want to make sure my answer is 25. So 919.21.
So it says wait till the final answer to run out.
So I'm skipping a step then. Okay. This is kind of like when I teach in quant. Okay, so to plug everything into your calculator, let me do that if I didn't round. Thank you for pointing that out.
15.0.
I got 919.18 when I did all of this.
Yeah,
So
So
if you were to break it down like that, that would work. So I got 918.18. So I guess because I rounded, you can see that my rounding error was way off. I went up to 0.21. But the,
919.
oh, yes, 919.21. So when I rounded too soon, that definitely threw my answer off. So. How do you feel about that? I know I'm making it worse. I know I am. I'm sorry. It's how I teach a different class when you get to be in 3410. Like, it's hard for me to go back to basics. But whatever Dr. Patterson says to do. So she says, wait until the final answer, wait till the final answer. Okay, now let's do it again. So calculate and round. So in this case, plug it all into your calculator. And since multiplication and division is in this, So pick the least amount of sig figs. Kind of helped you a little bit. When I plugged it into my calculator, the top by itself, I got 3 sig figs and 5 sig figs. That might affect your overall answer once you divide. Just because you're trying to round it to the specific amount of sig fig that's least.
So this one, we don't have to wait for the final answer for the one.
I didn't, so technically I didn't round.
Oh.
I want you to type it all in at once. The reason why I'm pointing this out is because when I subtracted these two and I followed the rules for subtraction, I didn't get 4 sig figs, I got 3. And your overall answer needs to be to the least amount. And since 3 is smaller than the 4, that's why you want to make sure your answer is to 3 sig figs. These questions are going to be very, very rare. This is just good practice. So I got 0.109. So my answer needs to be to 3 sig figs since 3 is smaller than 4.
So since you started with 4 sig figs, would that have to be 8.340?
With multiplication and with addition and subtraction, it goes to the least precise number. So it goes to the second decimal place. So when I subtracted them, it just 8.34 is the right answer.
Even though you started with 4 sig figs?
Yes, it's just, this is why we don't really hit on this in Gen Chem. I have a full section and when we hit quant. So I don't think you're gonna really be tested on this when it comes to exam. There might be like one question on it. It's good practice. And essentially you wanna get in the same ballpark, but this is like a good. I know I'm confusing you and I'm so sorry about it. But when I did this problem here, it's even though it's 4 sig figs and 4 sig figs, it's addition. So I need to make sure my answer goes to the second decimal place. So that's why it's now 5 sig figs. And if I compare them, my answer needs to be to 5 sig figs. Let me double check that one. My answer needs to be to 5 sig figs because that's the least amount. Let me correct myself over here. When I did this, my answer was to 5 sig figs. And that's why my overall answer needs to be to 5 sig figs. That's why. I don't know, I don't remember what questions were in the homework, but there might be some that help you practice these. Now we'll do probably 10-15 minutes of reverse. But I do want to point out a few things and then I can go over a couple of answers before we go for the day. I don't think we're gonna hit 1.7. So we'll do all of 1.7 on Wednesday. All right, so verse. I want everyone to make sure you have your formula sheet because I have the equation here and I have all of the variables. If you have to use the ideal gas law equation, which is PV equals nRT, R is a constant and I give it to you. I bolded it. So actually, let me switch to this camera. That might be better. So R right here is bolded because that's a constant. So if you ever need to plug in R, that's the number you put in there. Look at the units. R is going to be in liters times atmospheres per mole Kelvin. So you want to make sure that any units you put in there and you use this value, it has to match those units. Because N, I'm not going to mess with moles today, but N is usually in moles. It's a unit of amount. So you can go from grams to moles, but we're not hitting those conversions yet. R is the constant. I think I forgot. Oh, pressures down here. I forgot to enter this. This is a mistake on my end, guys. I'm sorry. So at the bottom of the first column, I have pressure and volume. That should have been here. So pressure is, for this equation, has to be in, let's see if I can zoom out. It has to be in atmosphere and volume has to be in liters, but I might give you volume in milliliters. You have to convert. If you have to use Q equals MC delta T, we've done that a lot. So I feel confident that y'all can handle those questions. So the verse assignment, let me see if I have. Here's that verse assignment. Just use the method. So variables, list out your variables first. Use the equation, and then you might have to rearrange and then double check your units. So go ahead. I have 6 questions. The first 2 are pretty straightforward, where I give you all of the units and you don't have to do any conversions. But I'll tell you now, after question 2, I start making you convert. Like for instance, this one's giving you something in torr, but I don't know how to convert from torr. This is a pressure. But if I go back to this equation sheet, I have some conversion factors. So if I want to go from torr to atmosphere, that's your conversion factor. Okay. So y'all go ahead and get started.
Pressure typically measured in PSI.
That's one of the, there's a lot of pressure units, bar, magnesium, sorry, mmHgs, that's like millimeters mercury, torr, atmosphere. There's so many different ones. And so typically when you get into unit conversions, like in Gen Chem and engineering, they'll give you like a giant like table of pressure itself. It's a lot of fun. Yeah. But we kind of assume that, for instance, we were just saying it's air rides around us, it's 1 atmosphere, because that's our atmosphere. Okay. Let's do 3 real quick. This problem is going to be the gas laws problem. So let's go do V for verse first, variables. We have pressure is equal to 874.6 torr. We have volume equal to 32.5 liters. Temperature is 348 Kelvin. And then R is 0.08206 liter atmosphere mole Kelvin. Now, what I want to point out is torr and atmosphere are not compatible. So I need to convert torr to atmosphere. And then on my equation sheet, I have that conversion right here, 765 torr is equal to 1 atmosphere. So if I want to get to 1 atmosphere, I gotta divide by 765 torr. Okay, so I'll do that math when I plug everything in. But the equation, so the E for verse, PV equals nRT, and it's asking for moles. So I need to isolate N. So I need to divide by RT on both sides. And so now I get N equals PV over RT. All right, so that's R for rearrange inverse. The next step is going to be E. I believe that's just make sure everything it's S. Convert everything you need to convert, and then an S is going to be plug in and solve. So let's do that. Let me do the math real quick because I haven't. Oh, I did it. Okay. It's 1.14 atmosphere. I believe I should have one more sig fig there, but I'm going to skip it. Y'all can correct it. It's what? 143? Thank you. So I'm like, I don't feel like typing that in right now. 32.5 liters divided by 0.08206. Sorry, I'll finish this real quick. Liter atmosphere over mole Kelvin, and then 348 Kelvin. So my atmospheres will cancel, my liters will cancel, and my Kelvin will cancel. And so my answer should be in moles, because 1 over moles equals moles. And my answer should be to 3 sig figs. Reason why is because this is all multiplication and division. And then this is the 3 sig figs, that is the 3 sig figs. I know I went through that fast. I'm sorry. My key is right here. It's under mole, the modules. It's at the very end. So even though the back of this has the answers down here, I wanted to go one step further and show you how I solved everything. So my advice is don't rely on the key. Please just don't have the key in front of you. That's not how you study. You have to struggle a little bit, do your best to get the right answer. And then if you really are stuck, go to the key. Or you got it, check your answers with the key. But don't rely on the key until you're ready to check, or if you're really stuck. But yeah, I have the key on both. Yeah, my sig figs might be off, but the answer and the process is more important for verse. Okay, have a great next couple days. I will see you on Wednesday. We'll finish 1.7, do the homeworks. My advice, do the homeworks and the quizzes now, and then Wednesday we'll start practicing for the exam.